While the United States developed its stealth fighter and bomber, it still faced the problem of how to protect its strike aircraft from intense ground fire and marauding enemy fighters. One solution was to build an aircraft that could fight its way to the target alone, bomb with pinpoint accuracy, then fight its way back home. The F-15E dual-role fighter was designed to do just that and became Tactical Air Command's newest Night Stalker.
In the 14 years that have passed since first flight, the F-15 Eagle, built by Mac Air, has dominated the skies of the world as the Air Force's air superiority fighter. And in this role, the Eagle will continue to defend the United States and our allies for many years. This new breed of Eagle, the F-15E, will retain that capability, but it is also designed to strike high-value ground targets in night and in poor weather. Its new mission, long-range interdiction, requires large payload capability as well as outstanding air superiority characteristics. Let's look at some of the changes that have been made to the Eagle, which is being displayed here. 60% of the airframe has been changed to make it stronger, giving the F-15E the ability to take off with a gross weight of up to 81,000 pounds and sustain a 9G load factor throughout its flight envelope. The same structural changes will extend its life expectancy to 16,000 hours of flight, or twice that of the earlier F-15s, and it will be able to carry up to 24,500 pounds of weapons. The low-drag conformal fuel tanks will add about 9,000 pounds of fuel. These tanks will carry weapons on stub pylons rather than on conventional carriage racks, reducing drag and thus stretching the range of the Eagle. That's just the airframe. The F-15E, as well as some recently delivered Cs and Ds, will be powered by two new Pratt & Whitney F-100-220 engines, which incorporate the latest in digital technology to provide better performance and better maintenance. Those of you who've seen the F-15 perform in air shows may find it hard to believe that it can accelerate faster or maneuver better, but that's what will happen with these new engines. For example, with a digital electronic control system, the F-15 pilot can accelerate from idle power to maximum afterburner in under 4 seconds, 40% faster than they could with the previous engine control system. Faster engine acceleration means quicker takeoffs and crisper response while maneuvering. The new engine is more maintainable as well. The digital system's components were designed with externally mounted modules that can be changed without removing the engine. This modular system has reduced the number of man-hours required to maintain the power plant by more than 50%. A system that automatically trims the engine will eliminate costly trim runs and result in a 6% savings in fuel costs. In addition, the 220 engine has an engine monitoring system that records engine data and faults, eliminating the need for manual tracking. It will substantially simplify engine troubleshooting and repair. And for the future, the F-15E has a new technology engine bay designed to accept other engines which may be desired to meet developing requirements. Mac Air has blazed a trail for the aerospace industry in developing a very sophisticated process called superplastic forming and diffusion bonding to help make this new engine bay. The process allows us to form larger parts from single pieces of metal, which reduces the number of fasteners and overall weight of the airplane at a lower manufacturing cost. To help guide the F-15E's crew over long distances in darkness and poor weather, several new avionics systems have been incorporated. The new inertial navigation system, developed by Honeywell, uses a highly reliable ring laser gyro to continuously determine the aircraft's position and provide that information through the computer to the various systems and displays in the cockpit, including a new moving map. This new system will feature reliability on the order of 10 times that of its forerunner. The Hughes APG-70 radar will find the target at long ranges. For example, from more than 80 miles away, at low altitude, the crew will be able to pick out bridges and airfields on the radar display. Nearing the target, the resolution becomes greater, and smaller targets, such as vehicles, are easily detected. The high-resolution radar is designed to create and freeze the maps during quick sweeps of the target area so that it may be shut down for much of the penetration portion of the mission, thus minimizing the opportunities for detection from enemy defensive systems. The E-model pilot will fly the aircraft with a new digital flight control system created by Lear Sigler. This system will feature an automatic terrain following mode, which will use information from the Lantern radar, and at the pilot's option, control the Eagle without pilot input at low altitude and at high speeds. For increased safety, the system will be triply redundant. The addition of these improvements will enable the F-15E to deliver weapons at night and in poor weather as accurately as today's best attack aircraft can in the daylight. These new systems will be manageable thanks to a complete update of the F-15E pilot's cockpit, but the most important addition to the F-15E is the new rear cockpit designed specifically for a weapons system operator. On 4 cathode ray tubes, the operator can display information from the radar, electronic warfare, or infrared sensors, monitor aircraft or weapon status and possible threats, select targets, and use an electronic moving map to navigate. 2 hand controllers are used to select the new displays and to refine the targeting information. Displays can be moved from one screen to another and are chosen from a menu of display options. In addition to the 3 similar tubes in the front seat, the pilot has a transparent glass screen called a heads-up display, or HUD, in front of him at eye level that displays vital flight and tactical information. As in all earlier F-15s, the pilot can select his weapon options and displays with switches mounted on the stick and throttle and without having to look into the cockpit. Already the safest fighter in the United States Air Force history, the new version of the Eagle will provide a long-range ground attack capability without sacrificing its ability to survive, since it will retain all its air-to-air weaponry as well as its speed and maneuverability. Protection from ground-based threats is enhanced by the triply redundant digital flight control system, self-sealing fuel feed tanks and fuel lines, fire retardant foam in the fuel tanks and voids, and a strengthened structure. Electronic protection is provided by an integrated internal tactical electronic warfare system. This system includes a radar warning receiver and active electronic systems designed to deceive enemy sensors. To confuse enemy infrared missiles, flares can be released and chaff can be expended to deceive enemy radars and disrupt radar-guided missiles.
Major changes have been made in the F-16C cockpit. These are designed to improve operational capability and flexibility. Directly in front of me is a new wide-angle heads-up display. It provides the pilot with all the flight information and weapons aiming cues he needs to keep his head out of the cockpit and on his target. The new HUD also has a raster capability for displaying a 25-degree field of view of infrared image. With an appropriate sensor, the pilot can navigate and deliver weapons by using the infrared imagery displayed on the HUD. Directly below the HUD is the integrated control panel. It's placed for easy upfront access to the navigation computer, radios, and the forward-looking infrared system. On both sides of this are 2 independent multifunction displays. They provide weapon and sensor control and large format displays of air-to-air and air-to-surface radar information, various sensor imagery, weapons and stores management data, as well as built-in test data. Prior to flight, all of the mission navigation, communication, and identification data, plus target and weapon information, are loaded onto this cassette. The pilot then inserts the cassette into the console receptacle, and all of the mission information is automatically loaded into the onboard systems. Of course, the pilot can modify that information at any time by using the upfront control panel. As in the F-16A, key controls are arranged so that the pilot, while in combat, can operate with his hands on the stick and throttle. For example, if while navigating or attacking a ground target, the pilot sees an airborne threat, he can switch to an air combat mode, automatically obtain a radar lock, destroy that enemy aircraft with an air-to-air missile or the gun, and then return to the original mode, all without moving his hands from the stick or throttle. Well, now let's get in the air. It's time to see these systems in operation.
Just like the F-16A, the F-16C is easy to start. No external support equipment is required. We only use one switch to turn on the battery and another switch to start the jet fuel starter. "30 seconds later, the engine is up to idle speed and the pilot begins his pre-flight checks and aligning the inertial navigation set. The entire process, from start to takeoff, can take less than 1 minute, but today we'll take it a little bit easier. With the data transfer equipment, the entire mission can be loaded into the aircraft systems in only 5 seconds. Carswell Tower, Dynam 5 for takeoff.
Dynam 5, Carswell Tower, wind 170 at 10, cleared for takeoff.
Dynam 5, roger. The excellent field of view from the F-16 cockpit is one of the first things a new pilot notices. With no canopy bow frame and a low canopy rail, he has an unobstructed view of the world outside.
Contact of 175, 72 miles. Looks like a flight of 2, Angels 10. Close out curves showing 78 miles. James, close out shows 25 miles separation. Turn it down.
How do modern strike aircraft penetrate deep behind enemy lines, elude enemy radar and air defenses? The answer is as old as the American Revolution. If you don't want to get shot, get behind a tree. This means flying behind the hills, and that means getting low, real low, down in the weeds, at the speed of heat. These pictures show what it looks like at 550 miles an hour at 300 feet. What they can show you is the way it feels, banging against the harness, your stomach in your mouth, with death a second's misstep away. In combat, of course, it wouldn't be this simple. It would be at night. Lantaran, developed by Martin Marietta Corporation, stands for Low Altitude Navigation and Targeting Infrared Systems for Night. It combines forward-looking infrared imaging, terrain-following radar, precision pointing and tracking, laser designation and ranging, and automatic weapons handoffs to minimize pilot workload. Pilots of the 4th Tactical Fighter Wing say they can drop their bombs within 10 meters, some say 10 feet of a target. This accuracy can be achieved using the radar and infrared navigation pod and by overflying the target. As the pilot goes into an attack, he maintains his overall situation awareness in the HUD. He finds the target area and positions himself with the infrared or FLIR sensor of the navigation pod. The final approach is then set up with the targeting pod. After target lock-on, the attack is flown heads up with all weapons delivery calculations and functions performed automatically. But for all its capabilities, it's really only a stopgap measure. From the moment the RCS number became significant, both the Navy and the Air Force knew they had to have a better solution. The F-117A played a part in finding that solution by showing stealth technology could hide an aircraft from hostile radar. But the F-117A has none of the high-speed cruise capability of the B-2, none of the complex computer-drawn curves that both vector away incoming radar and cut a clean aerodynamic profile. What was wanted, what was specified, and what has been designed in complete secrecy until now is the next generation of American fighters. The Advanced Tactical Fighter, the ATF. This is the Northrop YF-23A. one of two prototypes competing to be the ATF master model, to have the right to take over the leadership of the F-14 Tomcat and F-15 Eagle. The other is the Lockheed Boeing General Dynamics YF-22A. These fighters have been set an almost impossible goal. They must first incorporate the hard-learned lessons of stealth technology to be difficult or impossible for radar to identify. Second, they must be highly maneuverable to out-hustle an opponent like today's high-performance interceptors. Thirdly, they've got to be fast. The requirement is for supersonic cruise speed with military thrust. That means afterburners are out. Their engines simply have to be that much more powerful. Fourthly, the ATF must have an adequate payload, something similar to the F-15's usual armament of 4 Sparrow missiles, 4 Sidewinder missiles, and 940 rounds of 20mm ammunition. And finally, as if invisibility, maneuverability, speed, and strength aren't enough, the ATF will have to have sufficient range for all world theaters. The YF-23A has those qualities because, like a good racehorse gets its genes from its parents, a good jet fighter has to look to its own forebearers. In this case, because it comes from Northrop, the YF-23A need look no further than the V-2, also built by Northrop. What role will this fighter play in world affairs beyond the year 2000? What missions, under what authority, will it undertake through what enemy skies? The future is not yet an open book. But when that book is written, when the paramount importance of commanding the high ground has been driven home, yet once again, this stark aircraft will have been one of the major players. The ATFs.
Awesome. He's gone.